absolute value tells us how far a number is from 0 on a number line. Since distance is always positive, we know that whatever is inside the absolute value bars, it can be either negative or positive, is always going to give you a positive result. So therefore, to find out absolute value of one number, x, will give you positive 10, then x can either be negative 10 or x can either be positive 10, because absolute value of negative 10 is 10 and absolute value of 10 is 10. So therefore, when you solve an absolute value equation, it's always going to have two cases, and you're going to solve each equation individually. So the next one, we want to know the value of b such that when you add 13 and taking the absolute value of that, it will give you positive 23. This tells you that b plus 13 can either equal to positive 23 or b plus 13 can equal to negative 23. So to solve for b, you solve each equation individually. So for the first equation, to solve for b, you're going to subtract 13 on both sides. So we have 23 minus 13, so therefore b equals to 10. And for the second equation, I'm still subtracting 13 on both sides, but this time it will be negative 23 minus 13, and that will give us negative 36. And it's always good to check your answer to make sure it works. So we want to know if absolute value of b, which is 10, plus 13, does that give you 23? Well, 10 plus 13 is 23, and absolute value 23 is 23. So this works. And the next one, we're going to check to see if absolute value of negative 36 plus 13, does that give you 23 as well? Well, negative 36 plus 13 is negative 23, and absolute value of negative 23 is 23, so that also works. So this equation has two solutions here. So for our next equation, we want to solve for y such that absolute value of 3y minus 14 equals to 17. So this tells us that 3y minus 14 can either equal to positive 17 or it can equal to negative 17. So again, I'm going to have two cases here. So my first case is 3y minus 14 equals to positive 17, and 3y minus 14 gives us negative 17. So now I'm going to solve each equation individually. So for the first equation, we have 3y equals to, I'm going to add 14 on both sides, so 17 plus 14, and that will give us 31, and then divided by 3, so y equals to 31 over 3. And for my next equation, my steps are exactly the same thing. So I'm going to have 3y equals to, so this time you're going to add 14 to negative 17. So that will give us negative 3, and then divide by 3 on both sides. So y equals to negative 1. So now we're going to check our answer to make sure it works. So we want to know if absolute value of 3 times 31 over 3 minus 14 will give us absolute value of 17. So 3 times 31 over 3 is 31 minus 14 is 17, and absolute value of 17 is 17. So that works. So this is one of our solutions. And the last one we need to check is the negative one. So does 3 times negative 1 minus 14 and take absolute value of that, will that give us 17? Well, 3 times negative 1 is negative 3, minus 14 is negative 17, and absolute value of negative 17 is 17. So therefore, this equation also has two solutions. To solve this absolute value equation, we see that this absolute value of 3z plus 8 is being multiplied by negative 5. subtracted by 5, and then it's equal to negative 20. So in order to solve this equation, I need to isolate the absolute value. So in order to do that, we have to undo minus 5 first and then undo the multiplication of negative 5. So to undo minus 5, you're going to add 5 to both sides. So now your equation will be negative 5 absolute value of 3z plus 8 equals to, and negative 20 plus 5 will give us negative 15. And now to get rid of the multiplication of negative 5, so you're going to divide both sides by negative 5. So now my absolute value of 3z plus 8 is by itself. And that's going to equal to negative 15 over negative 5. That will give us positive 3. So now we are going to set up our two cases here. So now we can say that 3z plus 8 can equal to positive 3, or 3z plus 8 can equal to negative 3. And now we're going to solve each equation individually. So here we have 3z equals 2. So I'm going to subtract 8 on both sides. So we have 3 minus 8, and that will give us negative 5, and divided by 3. So our first possible value for z is going to be negative 5 over 3. And for our second equation, again, I'm going to solve for z. So this time, same thing. We're going to subtract 8 on both sides. But this time, it will be negative 3 minus 8. So that will give us negative 11 and divided by 3. So therefore, z is going to equal to negative 11 over 3. So again, it's always good to double check to make sure your solutions work. I'm going to check negative 5 over 3. So we have negative 5 times the absolute value of 3 times z, which is negative 5 over 3, plus 8, and then minus 5 equals to negative 20. So we know that 3 times negative 5 over 3 will give us negative 5. And when we add 8 to it, that's going to give us 3. And then absolute value of positive 3 is 3. 3 times negative 5 is negative 15 minus 5. And that does give us negative 20. So this solution works. And the next one we're going to check is negative 11 over 3. So we have negative 5 times absolute value of 3 times z. This time it's negative 11 over 3 plus 8, and then minus 5. Does that give us negative 20? So we know that 3 times negative 11 over 3 will give us negative 11 plus 8 minus 5 equals negative 20. So negative 11 plus 8 is negative 3, and the absolute value of negative 3 is positive 3. So 3 times negative 5 is negative 15, which minus 5 is negative 20. So this solution also works. To solve this absolute value equation, our first step again is to isolate the absolute value of x plus 1. So to isolate this, the first thing I need to do is to remove the minus x by adding x to both sides. So now my equation looks like this. We have 2 times absolute value of x plus 1 equals to 3x plus 1x will give us 4x, and then minus 4. And the next thing I need to remove is the 2 in front of the absolute value. So we know that this is 2 times absolute value of x plus 1. So to remove the 2, I need to divide it by 2 on both sides. So now my left side is just going to be absolute value of x plus 1 equals to, and I can divide all the numbers by 2. So I have 2x minus 2. So now I can solve for x. My first case is going to be x plus 1 can equal to positive 2x minus 2. And my second case is that x plus 1 can equal to negative 2x minus 2. So this time I need to put parentheses around 2x minus 2. So for our first equation, I'm just going to solve for x by putting x's on the left side and numbers on the right side. So we have x, and because I need to move 2x to the other side, so that will become negative 2x equals to, and now I need to move the 1 to the right side, so that will become negative 1 and bring down the negative 2. So now I can just combine like terms. 1x minus 2x is negative 1x. And negative 1 minus 2 is negative 3. And now divide both sides by negative 1. So my first possible solution is x equals 3. And for the second equation, the first thing I need to do is to distribute the negative sign. So I have x plus 1 equals to, so positive 2x will become negative 2x when I distribute the negative sign. And negative 2 will become positive 2. So now my process will be the same thing I did earlier. So we're going to put the x's on the left side and numbers on the right side. So we have x and negative 2x. If I move it to the other side, that will become positive 2x equals to, and I'm moving the positive 1 to the other side, so that will become negative 1 and bring down the positive 2. So now I can combine like terms. So x plus 2x is 3x equals to negative 1 plus 2 is 1 divided by 3 on both sides. So therefore x equals to 1/3. Now we need to check to make sure both solutions work. So the first thing we're going to check is x equals 3. We want to know if 2 times the absolute value of x, which is 3, plus 1 minus x, which is 3 again, does that equal to 3 times x, which is 3, and then minus 4. So we know that 3 plus 1 is 4, and the absolute value of 4 is 4. And 4 times 2 is 8. 8 minus 3 is 5. So this side is 5. And then the right side, 3 times 3 is 9, minus 4 is also 5. So 5 does equal to 5. So therefore x equals 3 will be one of our solutions. And now the next thing we need to check is x equals to 1/3. So we're going to do the same thing. So we have 2 times 1/3 plus 1 minus 1/3. Does that equal to 3 times 1/3 and then minus 4? So we can add 1/3 plus 1. So I can rewrite 1 as 3 over 3. So 1/3 plus 3 over 3 is same thing as 2 times the absolute value of 4 over 3. And absolute value of 4 over 3 is just 4 over 3 times 2. So that'll give us 8 over 3. And when I subtract that to 1/3, so that'll give us 7 over 3. And does that equal to 3 times 1/3 minus 4? Well, 3 times 1/3 is 1, minus 4 is negative 3. And we can clearly see that 7 over 3 does not equal to negative 3. So therefore, x equals 1/3 is not one of our solutions. So therefore, we only have one solution for this equation, which is x equals to 3.